here we are again. Now maybe a focus on the architecture and the objectives of the project, and then all the next, let's say, presenters will be able to hinge on those. So, of course, is a team. The real objective why we do all of this, and many of you here in the room are not only from a city-urban perspective, but also from a medical, hospital, operational perspective. And you very much know that new mobility solutions are needed in the medical field. When you go from left to right, and in the PDF there's no build-up, so I'll have to imagine. So there is a great trend towards centralization, the organization of networks. That, of course, if just applied to the existing saturated logistics situation, the road-based issues that we already have would not be very interesting. It would add, let's say, traffic on an already blocked situation, and thereby giving problems related to the implementation of centralized medical systems. Therefore, the current system, which is not really on demand, it's potentially leading to long waiting times, and there is also typically a reduced level of quality control. For that reason, actually, the arrival of new space, so the legal system, the framework available at European level, opening up possibilities in unmanned aviation is very interesting. That goes in parallel with drone technology. So the unmanned aviation technologies are maturing. That is linked to, of course, also the miniaturization evolutions that we have seen in the past in industries like mobile telephony, telecommunications, and so on. So basically, that's actually where we need new mobility solutions. And then the question is, okay, for what use cases would we then apply it? And again, from left to right. There are use cases that are, let's say, well within scope, where we talk about inter-campus medical transport, and this is related to these networks being formed, groups of medical institutions that are relatively closely situated one to each other, and which have quite some interactivity as to volumes and frequency. And examples are anatomopathology lab, clinical biology lab, the hospital pharmacy with the clean rooms. A second range of examples are use cases at a larger distance, where also the scale is more, let's say, not so intensive, but still very interesting to hinge into that system, and that is, let's say, blood supply from the central collective measures. So I'm the only one who's actually looking at the slides. Sorry for that. So speaking to your imagination now, let's say a third group of applicable use cases would be more complex as to conditioning, would also be international in nature, like, for example, organ transport. And then a next level up is even, from an aviation perspective, another challenge to fly a defibrillator drones to unknown, let's say, locations from the start of a flight. So meaning that we would have need for systems of a free routing type. So that's the next level. And what we call the Queen's categories, of course, patient or doctor transport is passenger-based drones. And these things might sound, let's say, very future-oriented, but actually in SAFIR-Med, these applications are already in scope. And so at our in our project, we do indeed have an AED drone with TU Delft that we're flying and testing out. You see also in the news quite a few activities around that sphere. And the same is true for the passenger drone. You've seen below the Yang drone, part of our project. I see more is failing. So this is about the use cases. I've already mentioned let's say we have a few objectives, right? So the first key objective we've spoken before about it is urban related. It's how do we, what is the role, let's analyze the role of society and the urban centers, the local authorities, as to how they will perceive and what is the impact on urban air mobility systems. The second two objectives are related to infrastructure. The first one is about safety, the other one is about environmentalism, so the sustainability. And then our fourth objective is about demonstrations. That's the way in which we do research in the typical European framework, is that also we demonstrate what we do, so that there is a feedback loop from that level, and to also demonstrate not only technologies but also the full service model. So that's also why we have this full integrated ecosystem here on stage. And the final one, the fifth one, is then, okay, let's not only do it in a small group, developing technologies, demonstrating each other and evolving what the solution is, but also to disseminate, to bring it out to the public and to let, let's say, the wider society get used to these new technologies, because we all know that unless the public accept this, we will not have much progress. So that's the fifth, let's say, objective. Then the it's a dancing screen. So basically how we structured the project is that we will do what is called, we'll follow the approach of a VLD project, a very large demonstrator project, meaning that we'll do first a series of tests, joint de-risking activities, where we'll integrate our solutions, where we'll start coordinating our crews, and we've done the last few days a lot of activities on that. So we've been here all together, running through the scripts of the different scenarios, and really step by step going through the use cases and let's say preparing ourselves for then flights that will happen in Belgium at Antwerp, Mechelen area, and in the Maal region in Aachen-Heerlen. And then finally also we'll do an extension to these processes in Prague and Athens, where we'll also go through let's say simulated use space exercises to see, okay, how would those areas also interact with these type of solutions. This image you already know. This is, let's say, the process flow, a bit easy to understand. Behind that, actually, there's architectural drawings like these ones, and then you start going lower. I'll not show what solutions are behind each, because then we're basically at the IT layer, but I think this one is still very understandable. And so if you go from the right to the left, you see there the drone service consumers. And basically, let's take the example of the hospitals. We get an order which goes straight into the operator side. In this case, Helicus is acting as the operator, taking the order through a system that was validated also with many of the medical practitioners here in the room, powered by NSX technologies to have a scalable, powerful, let's say, solution from the IT side. And that element is then passed on to the drone platform, the solution vehicle that is applicable for this task. So we've seen multiple use cases. Well, each of them has actually a different vehicle, a different solution that is required. And there we have Sapcat, Delft, FlexDrive, HiFly, and eHang that form solutions that are all connected to receive, let's say, the flight paths. And then we, of course, we have maybe a solution, but we don't necessarily have the authorization. It's not necessarily safe to just take off and go there. So that's why we go into the red block, which is the use-based service provisioning structure, where we have Skydrone and Dronic, who are acting as what we call the USSPs. Yeah? And they, let's say, provide information, traffic information to operators like Helicus. And based on that, we shoot in requested flight path. We get authorization back from that same USSP, Skydrone and Dronic. And then we know, okay, we are authorized to take off. This information is passed on to the drone. We go for takeoff. And then actually there's also some other information that's used. And this is represented in the blue bar, which in the future concept is the Common Information Service Provider. SKYS is on that layer. The SKYS is the ANSP, the Air Navigation Service Provider. So the current air traffic control, you would say, for Belgium. And this is a type of activity that falls in their domain. They get information statically from the competent authorities, the civil aviation authorities on the bottom left of the screen. Then the ANSPs and air information management providers, they feed in information. We have the local authorities who also have information. For example, we have a special activity, a conference on the ground, or some activity. Maybe best not to fly there. Why extra risk if by flying a few hundred meters away, you simply lower the risk, even though nothing would happen, but just minimize, let's say, latent risk, right? Then you've got also consumers, official consumers of those systems, like the police or firefighting, that actually might be, and I see some colleagues from Aachen, I think, or yeah, FOIA, yeah. That actually are official users of this data in order to also be able to ensure their public role. Yeah? And also we have authorized data providers like one partner, Involi, in our project, who provides actually information from the ground as to where objects are flying, and that is injected back into the system via the USSPs and is then available for the full tracking. So this gives you a feeling of how the systems work. And then on the bottom right, we have a lot of very important partners like Baloise. We need insurance to get all these things working, because even though we think there's a very safe system there, there might always be issues. And if that would happen, it has to be correctly solved and further analyzed and improved, and we go in a cycle of continuous improvement. We also have the cities there, and we spoke about Sataken also, City of Antwerp, who is in the advisory board. We have the University of RWTH and UC, who are putting in place different solution blocks. Maybe very dry slide, but just to list a few things that will appear in the other let's say sessions. So first of all, we have what's critical, a centralized beyond visual line of sight command and control center that's in place. This is quite important. You heard in the economic, let's say, presentation of Aphrodite that actually the automation, the integration is extremely important to get to an economical feasible situation. So that's why we need beyond visual line of sight operations, that you don't have a pilot always there, but it's beyond this visual line of sight of that individual pilot. So that's a key point, and that's why you need remote command and control centers that are able to do so, and that's what we're doing. And so we control from, for example, Antwerp, from the Helicus Command and Control Center, we control the TU Delft flights in Valkenburg, or the FlexDrive flights in Aachen, the SAPCA flights that was in Belgium, but okay, it's the same principle. So these are the things that we have to build, experiment, and to enable economic feasible solutions that then are societal relevant. Because if we don't have something that's feasible, then also our medical community will not be able to use them. And therefore also the order intake, this needs to be validated in a correct way, and that's where we are partnering with 44 partner hospitals, the Red Cross as well, also here today in the room, very strong partners to, let's say, make sure that whatever we develop is also applicable to the real user. Yeah? So we also therefore have found out we need a multiple type UA fleet, unmanned aviation fleet, and indeed we have here in the project 5 platforms, 2 rotary wings, 2 VTOLs, vertical takeoff and landing craft, and a passenger drone. And then also what I just mentioned, you remember the red block, the USSPs, unmanned service system providers, are from 3 countries actually here available, here also in the room. This is new solutions, new type of technologies that we have to all, new actors actually, that we have to combine to get this system up and running. So that's key on how such a thing can work. And another block, you might not think, for the operational authorization. We have spoken about getting authorization for individual flights, but actually we need a framework within which we can fly, because it's a total new activity, and therefore the Commission, based on, let's say, legislative activity from EASA, the European Aviation Safety Agency, requires us to create what we call SORAs, specific operational, let's say, acceptance permissions for actually very different platforms, very different urban air platforms and systems, and this is a big chunk of our work. I was saying, like, yeah, we have to show the use space services, but actually our biggest work, I don't know, 70–80% I think is about obtaining actually the operational authorization, also because it's also new, and we have to help each other between the, let's say, legislator and the industry to collaborate on that. So the operator organization is, of course, there a very important one, because that's the entity that actually receives then an operational authorization based on an operating manual, based on a safety management system with strong procedures and also incident reporting. So if something happens in aviation, that's not the end of the world, as long as you know what it is, as long as you put in place a countermeasure, and as long as you can then, let's say, ensure that it will never happen again. That's the trust-based world. That's how aviation became as great and safe as it is. Then we have formal trainings. We have syllabus classes made for safe multi-company crew operations. And we have also not important, together with the cities, ground mitigations, ERP, emergency response plan, that we put quite some time in to make all this package available. My time is running out, so just mention the 3 technologies that we're developing. And so on the use-based services, we're doing a lot of work, also in integrating those throughout the partners. On detect and avoid, traffic-based detect and avoid, it's fantastic. I think Dennis will have a fantastic talk about that coming up. We have got mission privatization, which is very new, unknown, that actually unmanned aviation would get the priority that might be higher than a manned aviation flight because of its social medical mission. And then finally, we have to apply very new legislation set, so the 2019, the 945 and 947, where an interesting Article 13 is the one that would make flights possible also in the different countries that we, the 3 countries that we actually operate SAFIR-Med in. So I hope this gives you a kind of overview of the situation. And then I would like to introduce the next speaker.